Lousewort is one of the most characteristic wildflowers of heathy places, very typical of the margins of bogs, for example. And like a lot of its close relatives in the snapdragon family to which it belongs, it's semi-parasitic on the roots of grasses. It gets its nutrients from the grasses and then manufactures its own food from those nutrients. It's a member of a big genus. It has about 350 species. The genus is Pedicularis, spectacularly diverse in China, which has almost that number all to itself. But it's certainly not the most eye-catching of plants. You can see it's very low growing, very inconspicuous, usually in small little clusters as we have here. And the small leaves are somewhat oak-like perhaps in appearance, short stems and tight clusters of flowers in which the individual flowers seem to be disproportionately large for the size of the plant. The corolla is two-lipped, the lower part curved to form a long downward narrowing tube 10 to 14 millimeters deep, at the bottom of which nectar is secreted. When you look at an individual flower, it has a somewhat squashed look to it. You get the impression that it's not quite as bilaterally symmetrical as you think it should be. In other words, the plane of the lower lip is not quite at right angles to the plane of the hood-like upper lip. But when you look at a number of flowers, you realize that in fact all the flowers are like this. Lousewort is a classical bumblebee flower. But of all the bumblebee flowers in its snapdragon family, few are as intricately complex in the precision with which the different parts of the flower work together to optimize the chances of successful cross-pollination by bumblebees as is Lousewort. Two little pointy structures divide the opening in the hood-like upper lip into a narrow upper part through which the style and stigma protrude, and a wider part below this, which is just wide enough to admit the bee's forehead. The yellow anthers are visible behind the stigma. The style is closely pressed against the curved ceiling of the hood and is curved sharply downwards as a result. Below this wider part, the opening narrows again and the margin folds back on either side to form two folds that are studded with tiny spikes, which inhibit movement by the bee in this direction. The head of the bee comes into immediate contact with the stigma, so that any pollen it may be carrying from another flower is transferred. The lower lip is the landing platform for the bee. It's made up of 3 petals joined at the base, and in the centre there are 2 ridges, a brighter pink than the rest of the flower but white on top, with a deep and narrow groove between them. The stamens are under the style, behind the stigma, in 2 pairs, 1 pair in front of the other, the 4 of them kept firmly locked together by the tight sideways compression of the hood. The anther openings face each other tightly, so that pollen is shed into a little box at the centre. As the bee squeezes through the opening, having first brushed against the protruding stigma, the sides of the hood are pulled apart, assisted in doing this by the slight angle of the bee's body on the sideways tilted lower lip, which explains that slight asymmetry we noticed earlier. This separates the lower edges of the anthers, so that a small amount of pollen falls on the bee's head exactly on the spot which came in contact with the stigma a fraction of a second earlier. Hairs on the silvery filaments of the longer stamens help to prevent wasteful spillage to the sides. The flowers are entirely self-incompatible, completely dependent on visits of the larger bees to which they are so particularly adapted. I can try dissecting the flower to show you what happens. It's easy enough to dissect the lower part of the corolla tube, but the tissue in the hood at the front, here, is much tougher, in order to make absolutely sure that the anthers inside remain locked together and to keep the style at the apex of the curved hood. And it resists any attempt to use a scalpel without rupturing the rest of the tube. And if the hood is opened, the 4 anthers simply fly apart. All of which shows the precision of an arrangement where only movement of the bee that has been delicately choreographed by the design of the flower can cause an orderly discharge of the pollen, after which everything returns to where it was before the bee's arrival, ready for the next visitor. But if I do use a scalpel to cut through the lower part of the corolla tube and the scissors to dissect the cowl-like top of the hood, this is what we will see. Lousewort got its name from John Gerard in the 17th century, who was the first to describe the plant in English. And Lousewort is simply a translation of the German word Läusekraut, Lousewort, from the belief that cattle grazing in pastures which were rich in Lousewort developed lice. But of course this has nothing to do with the plant. It's a result of the poor forage quality of the habitat in which Lousewort grows.